गाड़ी का क्या
रोहित सर, हेलो, गुड मॉर्निंग। ठीक है, आप ये लाइव भी दिख रहा है मुझे। और
Let the participants join first. Hello, Rohit sir. Mathur sir. Good morning. सर वो लाइव स्ट्रीमिंग का लिंक भेज सकते हैं चैट पे। यस सर। सर
Good morning from India, Chetan. It will be, I think,
How are you?
even I'm good.
Yeah, it's slightly late, but no worries. Happy to be here.
Thank you so much.
Yeah.
Sudendu sir.
Yeah, ma'am, we'll wait for
Good morning
another
from India, Chetan.
2 or 3 minutes, then we can start.
It will be, I think,
How are you?
even I'm good. Okay.
Yeah, it's slightly late, but no worries. Happy to be here.
For thank you so much. Some
Yeah.
more participants are there. Sudendu sir.
Yeah, no problem.
Yeah, ma'am, we'll wait for
Good
another
morning from India,
2
Chetan.
or 3 minutes, then we can start.
It will be, I think,
How are you?
even I'm good. Okay.
Yeah, it's slightly late, but no worries. Happy to
We
be here.
are streaming. Thank you so much. Some
Yeah.
more participants are there. Sudendu sir.
Yeah, I saw that.
Good
morning from India, Chetan.
2 or 3 minutes, then we can start.
It will be, I
This
think,
one is also
even
is going to be live. I hope
okay.
everything works out. It's
Yes.
slightly late, but no worries. Happy to
We
be
are
here.
streaming. Thank you so much. Some
Yeah.
more participants are there. Sudendu sir.
Yeah, I saw that.
Good morning from India,
2
Chetan.
or 3 minutes, then we can start.
It will be, I
This
think,
one is also
even
is going to be live. I hope
okay.
everything works out. It's
Yes.
slightly late, but no worries. Happy to
We
be here.
are streaming. Thank you so much. Some more participants are there. Sudendu sir.
Yeah, I saw that.
Good morning from India,
2
Chetan.
or 3 minutes, then we can start.
It will be, I
This
think,
one is also
even
is going to be live.
To this fourth day of PDP on AI-driven VLSI design and optimization, organized by Department of ECE in association with MUJ Tech and HR Department, Manipal University, Jaipur. Today, we are privileged to have with us our eminent guest, Mr. Chetan Arvind Patil, to this fourth day semiconductor PDP on AI-driven VLSI design and optimization, and organized by Department of ECE in association with MUJ Tech and HR Department, Manipal University,
Mr.
Jaipur.
Chetan
Today,
authoritatively comments
we are
on
privileged
chip
to
design
have with us our
application
eminent
in
guest,
strategies,
Mr. Chetan Arvind Patil,
EDA,
to this
and
fourth
use
day
supply
semiconductor
chain
PDP
designers
on
through this widely
AI-driven VLSI design and optimization, and organized by
Northwestern
Department of
University
ECE
alumnus.
in association
With a global
with
guidance of
MUJ
over
Tech and
14,000
HR Department, Manipal
professionals,
University,
Mr.
Jaipur.
Chetan's complex
Authoritatively
manufacturing
comments
and
on privileged to
strategic
design with
insights,
us our
application
eminent guest,
actionable
Mr.
guidance.
Chetan Arvind
We are
Patil,
truly
to
privileged
this
to have
fourth
him
day
supply
semiconductor
chain
PDP
designers
on
through this
AI-driven VLSI design and optimization, and organized by Department of ECE in association
I'm sure
with global
will be
guidance of MUJ Tech
enlightening
and
and
HR Department, Manipal University,
Mr.
Jaipur.
Chetan's complex
Authoritatively
manufacturing
comments on
and
privileged to
strategic
design with
insights,
us our eminent guest,
welcome
resistance. AI we are
Thank you. Thank you for the introduction, and I'm really happy to be here. And without taking much time, I'll share my screen and we will go through the presentation. And I will explain how I structured this particular session. And then at any point of the time, if there are questions, then feel free to interrupt, and I would be more than happy to answer as we go along with the session. And without taking much time, I'll share my screen and we will go through the presentation. And I will explain how I structured this particular session. And then at any point of the time, if there are questions, then feel free to interrupt, and I would be more than happy to answer as we go along with the session. And without taking much time, I'll share my screen and new age of artificial intelligence is getting into the product development phase. And uh, and a brief about me, I focus mainly on the automotive products currently, where I focus on the yield aspect, quality, reliability, and design and manufacturing also. In close collaboration age of artificial intelligence is getting into the product development phase and globally. And prior to this I was also in a brief about me. I focus mainly on the automotive products where I was working currently, and then where I focus on the before that quality, reliability, and design and manufacturing, the computer architecture. In close collaboration age of artificial intelligence is getting into the product development phase and globally. And writing on my website, prior to this I was in, and of course in brief about me. I focus mainly on the automotive products currently, and then where I focus on the before that quality, reliability, and design and manufacturing, also architecture. In close collaboration age of artificial intelligence is getting into the product development phase and semiconductor manufacturing side, design side, applications, and everything which is not of course interacting with me. I focus mainly on the automotive products currently, and where I focus on the quality, reliability, and design and manufacturing, also architecture. In close collaboration age of artificial intelligence is getting into the product development phase and semiconductor manufacturing side, design professionals and apprentices, which is not of course interacting with me. So the way share information about how one can integrate themselves as a semiconductor engineer regarding how to utilize tools to make themselves more productive. And the goal is not to showcase how to develop models or any kind of those aspect, but to use those models for your own benefit. Because what I believe is that when you share information about how close to 80 to 85% of the semiconductor as a semiconductor engineer focused on the planning phase where exactly you're targeting your products. Then you do the research development where you bring different teams together. Then you start the design processes. Then you go through the manufacturing when the design has been locked out. And then you start doing your validation, testing, reliability, qualification. And then you go through your finance and making sure your customers are happy. Is the planning phase where exactly helpful in terms of integrating itself. And one aspect which is already there in the manufacturing side is more about yield improvement, where you are pushing your products on a wafer through different equipments, and you want to auto capture the images, the data, and then analyze it on the go. So these kind of process steps are already available and deployed, where you have kind of manufacturing execution systems which are uh, on a day-to-day basis are not only just collecting the data but also monitoring it, analyzing it, and then presenting it to the engineers who would actually process this. And it also means putting some kind of smart alerts or some kind of smart hold, so that if something goes wrong during the mass production or mass volume manufacturing, then you can go back and look at the data. So these are the big use cases which are already available in the semiconductor industry. But the main thing which is going to happen as we move along and start using it much more aggressively, the smart solution, you say, or much better computation for developing product or simulating any kind of analysis would actually reduce the time to market. So nowadays, you take around any product takes around 6 months to 12 months of cycle time. It includes different process steps from design, verification, tape out to validation. So the goal would be that you use these kind of solution to minimize the ability to deliver the samples to your customer, which basically means the design to your customer. And eventually, the goal would be to ensure that the cost is optimized also. And all of this will depend upon how your product is aligned to use these tools. So nowadays, the first phase where things are getting integrated is on the electronic design automation tool side, where there has been a push to use those smart data collection strategies to understand if the database which is available can be correlated or can be smartly integrated to reduce the setup time, or your analyzing the cadence flow or any kind of tool flow. But one thing which that comes into this process step as a risk factor is that since silicon industry is mainly driven by IP and the innovation or the patents, so you also have to understand that not everything can be exposed to some kind of tools that you can help or use. So there comes a balanced nature of how much deployment can happen, and that is also the reason why you will see that the adoption rate in semiconductor industry will be slow, because every company would want to develop their tools in-house rather than exposing their database to outside, because there is always a process of a leak or any kind of gap in the system which could lead to negative impact. Now, in another aspect of what we need to understand is what AI does not mean for semiconductors. That is not about replacing human engineers. It's actually about substituting or actually enhancing their productivity so that they can focus on the more critical areas rather than doing the redundant task. Like if you're doing anything which is, if on a day-to-day basis, if I'm looking at a data, I'm doing the same thing again and again, writing, looking at the data and loading the tool. If I can automate that and then it can present to me the information, then I would be making myself more productive. So that's the goal of AI is it will be more assistive in nature, and it will also depend upon where you can deploy and where you cannot deploy. Because if you look at the image on the right, there is different section which I showed, which was from the Deloitte report. But we also need to understand where exactly the your investment is going to make sense. So it doesn't mean that you just deploy some kind of tool or some kind of magic solution and everything will happen on its own. It doesn't work like that. So it's mainly about finding the areas where you will get the maximum in return on your investment, and then making sure that those are the areas where AI can be integrated. So definitely it's not a solution that will fit every aspect of your silicon process step, but it's also about understanding those repeated process steps which can be replaced by these kind of smart solutions. Now, in this line, what I did a couple of years ago, wrote an article where I said that, it was published by Electronics for You magazine, and it was more focused upon why we need to understand that if whether it is design, manufacturing, or workforce like us, mostly the focus of AI would be in an assistive nature. Where, for example, you have just joined the company and you have no idea about how to set up the tools, so you may be able to have an access to the AI system where you can query, I am working on this project, which tools I need, and then that can give you an idea about how to exactly process the steps and make sense of it. Or it could be about you have a documentation you have to read, you have like 10-20 pages to read, so you can put it into a model and then try to extract specific key points about it. Maybe you are working on a new project where you have no idea about what the past history, so you could go to this internal tool system if it's available, and then query exactly what was happened and what was the design issues, what was the data points, where exactly the yield loss were. All those kind of summary could be captured, which as of now, until few years ago, or even today, are actually driven by human knowledge. If somebody would train you or somebody would transfer you. So that's where the assistive nature will come into the semiconductor industry, and you will start looking at different way of getting people trained, different way of learning new skills or reskilling yourself. So that's where the AI will integrate itself into the semiconductor product development phase. Now, one more thing which we need to understand is that what are the use cases of the AI in the semiconductor industry. So there are different aspects which I shared in a couple of slides ago, but there are mainly two areas where things are actually going to be more impactful. Definitely driving the development and to research phase, where you are improving your product compared to the last product by using some solutions that will help you aggregate the information faster, maybe find the bugs for you. Maybe they can look at your RTL and then say, hey, if this device characteristic really fits your requirement or the target specification. And definitely on manufacturing, it's all about yield. It's all about making sure that the process you're developing is actually achieving the minimum required yield, or how much percentage of good die you can get out of the wafer or the package solution. And if you don't have an yield process where you're not always improving or achieving your yield, you're actually breaking your ROI process or ROI journey for that particular product. And that's where it becomes important to understand how and where exactly in the process step. For example, in fab process, when you log the design and you send the GDS out and they start making mask, so there will be robotic scanning happening to make sure that every mask step which has been generated is actually right. And then when the mask set are translated into the wafer using different process steps from etching, lithography, deposition, and etc., then you would be looking at the data at each of the point. So the human way is not possible. You cannot go and look at each of the wafer. If you're running, let's say, 100,000 wafers a month in a fab, so that's where the smart solutions come in. So in a sense, AI industry or AI manufacturing industry in semiconductor is actually few steps ahead in using automated systems, which we can call as AI because you don't need any human interference. It's the design phase where we will be seeing more and more innovation happening and usage of much better tools than we had a few years ago, and making sure that you are able to actually do your design in a different way, not just looking at your resistor capacitor and making your RTL from scratch. Or maybe you can create your design by combining different blocks from the previous IP of the previous revision, and then making sure that you can enhance it a step further. So, semiconductor industry as such is one of the areas where AI is going to be very useful, but it's also about understanding the risk factor and then focusing on the key areas within the process step where it will be really will actually make a difference. Now, one of the things about AI and semiconductor is that there are two perspectives which I have come across, and which because semiconductor industry is in a process step where you also want to use new solution to improve your manufacturing and design, but you're also catering to industry which relies on your solution, like software industry relies on your uh, silicon chips to make your next step. So for example, it's like a chicken egg situation where I want to create a better model, but I need a better silicon chips. So if I need better silicon chips, then I need better manufacturing of semiconductor process chips. So how does this perspective come into picture and why it is important? Because uh, it's all about understanding how AI impacts the semiconductor design and manufacturing, and also about how the semiconductor industry uses AI to gain market and business advantages. So if you are somebody who is from the technical background, you would be more interested in the step one, sorry, the perspective one, where you are trying to understand, I'm a design engineer. I don't care about I don't much care about the finance aspect or marketing the team there, but my understanding, my focus is how to use new tools and solution to improve my productivity. So it could be about uh, making sure I have plethora of information available with me about any kind of techniques which I have learned in the past, so I can visit it quickly. So you might want to have those kind of tools available to us. If I'm as a product engineer, I have to focus more on the yield. So I want to deploy solutions where I can actually capture the yield issues on the fly, or notice that any excursion on the fly. So for that, can I deploy some kind of advanced skills that can process large amount of data and then present a summary report to me? So that kind of perspective I would be interested in. But if somebody is there from the finance or business background, then they are actually looking at AI as a market, where, for example, you are looking to develop chips so that you can cater it to the workloads of advanced models, advanced applications, advanced frameworks. So if you look at the journey of the recent development of transformers, the generative transformers, and how the industry is heading towards generative AI. So that industry requires you to have AI solutions which can actually process data at a very high rate. So it's all about understanding where one as a professional which side you are on, and then use that technique for your benefit. So if I am somebody who is more interested in the revenue, then I would like to deploy processes so that I can cater to solutions, develop better SOCs, better power performance profile, better die area. So how all those can be done with the use of AI solutions, so that I can actually back up my computing industry with a better chip design. So in a sense, this pictures depicts it very nicely, that when you are in the manufacturing fab, you are actually using AI-enabled solution to manage your wafers or manage your process steps. But what ultimately you are doing is that you are using this solution to create different kind of uh, different kind of SOCs. For example, you're creating GPUs, you're creating RAM, high bandwidth memory, or interconnect. So this is the reason I call it as two perspectives, because it's it's also about using AI solutions to enhance your next AI products for the market. And it's also about making sure that you are able to rightly use and deploy the process steps. So as an example, in manufacturing uh, plants, so if you are going through different wafer process steps, so there would be a robotic arm that will scan the wafer for every wafer, and the goal is that you take the picture, and when that wafer is diced and converted into package, then you also want to take the picture of it. And the reason you do that is to make sure that the product you're developing is actually meeting the high quality requirement of your customers or the market you are, or the target application. Now you cannot do this manually. So you take the picture, you see if everything is right, and then you process the package part to the next step. Anything that doesn't meet the requirements is then left out or is scrapped. So this is how the AI integrates from the two perspective in semiconductor industry. It's not just about using AI to better your product development, but it's also about using AI to develop better AI products for your AI market. Now, when it comes to semiconductor product development, there are different process steps which are involved. And the reason these are defined like this is because every product you develop, every chip you bring to the market has to be meeting the required strict standards of the industry. As an example, if you are making a silicon solution for your automotive product, it needs to work in the field for next 5 to 10 years, at least 10 years at the minimum. And if you are using alternate energy, let's say electric vehicles, then the life becomes slightly higher because your batteries can be replaced easily and your components might run a longer time. So every product which we develop in the industry goes through this semiconductor wheel, where there's a R&D phase where you need to know which materials to use, equipments to use, IPs which you are developing, how it will be designed, manufactured, packaged, and how it will be put onto a final printed circuit board if multiple chips are coming together, and then the customer will use it. Now, imagine the scope of using your how much amount of effort it takes to qualify or bring one chip to the market, and multiply that by number of total solutions. So maybe let's say close to there are 10,000 different kind of products available in the market. Actually, there are many more. So each of these products will have to go through these process steps, and you cannot. And given that the way industry is heading right now, we are close to 700 billion market cap in the global arena, and by next 5 years the goal is to double it. Now if you can only double it by two ways: either you introduce more products or increase the number of manufactured product per existing products. In any way you take it, you are going to actually increase the complexity or the process step for each of the uh, process flow I'm showing here. And then it becomes important to capture those process steps where you can actually see the real benefit of using AI. So there are two ways to look at it. One is the research community, where the researchers are coming up with few ideas, and then there is a commercial angle where the industry or the specific domain is already deploying it. So I'm going to focus more on the research example, which are already available in form of like research papers, and try to give you an idea about how exactly the AI solution will integrate and where exactly it will take in. Now, if you look at so this was a overview of how the product moves from an idea till the customer. But when the product has to be qualified, like has to be developed from step to step, then you have to follow these flow, where you have to understand if the product you're developing really makes sense in terms of the ROI. So you do not want to make a product if it is not giving you at least 1.5 to 2x return. And then you want to then gather the team, design, translate it, then the process step which we all know about: verification, reviewing it, locking the design. So there are few steps which I've highlighted in red, and the reason to highlight it in red is that as of now, the way industry is heading is that they are trying to look into the intercepting AI solution to these kind of process steps, where you are working on the design steps, then how you can make sure your process steps are done faster. Then during the verification, are there areas where the bug analysis can be done by an automated system with the help of a human engineer? And then during the fabrication process, where I already said it's slightly advanced than the design stage. And then assembly testing is also area where things are being taken to the new level, where you can actually look at much more advanced process node. Let's say if you're looking at 3 nanometer, you have more than billions of devices inside it. So how do you narrow it down in case something fails? So how do you go inside that package, which type of equipments to use, and then if you cannot drill down after a layer, then how do you regenerate those kind of uh, uh, images, or exactly mass which is needed for those dies. So these are the areas where things are getting where the AI solutions are getting deployed. But slowly there will also be the standard areas from finance, marketing, and business, where also the advanced tool will be used, which is already in use, where people can make their business studies faster, understand the market research analysis better, because instead of going to Google and searching, you can now query a system and then it will start working on it. So first example is from the design perspective, and I have taken this from the research paper called Chip GPT, which is inspired from Chat GPT. And what they are trying to focus here is that once you have a design phase available, then you can process all those steps through a already trained model, and then try to come up with some initial raw base program and some kind of analysis for your target application. So these all is actually fed into the system, where they have already trained. Actually, they've taken the reference model, and then they have incorporated much slightly better techniques to make sure that you can get some tailored answers to your questions. And then the output of this would be whatever you need, but you can also tell the system that you want to look at. Just give me, these are my data sheet specification, this is my parameter, this is my market target, this is my area constraint, tell me which node I want to use as an example, which process step will be better. Or if you already know about the process technology you're using, package solution you want to cater, you have die areas already logged in, then you can feed it into the system, and it will actually create some kind of analysis so that you can actually get started with your design at a much higher level, rather than creating everything from scratch. For example, setting up your design database, then assigning blocks to different owners. Maybe the future design stage, or already existing in some of the companies, would be to gather this information in a different way, and then instead of starting from scratch, you are actually starting from at a level where you already have a reference solution ready. And this is mainly from the tooling side, where you see the EDA tools which are already fairly advanced, but you have to still go through your remote log into a system, set up your database, look into the cell libraries, and arrange everything together, and then run the simulations. So those things which are repeated tasks from project to project can now be automated, as long as you're open to opening up your database to a system which is slightly smarter than us. Now, another aspect of EDA is where this another solution which the researchers have come across is called a Chat EDA, which is again inspired by Chat GPT. But the focus here is that instead of writing your any kind of scripts, or any kind of, let's say you are running some kind of analog mixed signal solution, or you're doing some DV verification or analog verification, and you have to write a code in Python, then instead of writing the code from scratch, what if I can tell that my design is XYZ, and my utilization, and these are my features. Can you create an initial template of code for me, so that I can review it, and then run those kind of verification on that particular database, which RTL, which I have available with me. So this kind of prompts would be useful when you are actually working on a complex chip design solution. Let's say if you're working on a SoC which is which is using fairly advanced process steps, and the number of features would be increasing, number of specifications would be increasing. So you might want to use a tool which can help you actually make your speed of development slightly faster, because nowadays even a few years ago you would be looking at somebody writing the templates from scratch, and then it takes time, and then if there's a bug then you go back and fix those bugs. So what if there is already a way that certain level of information is generated for you, and then you review it, and then you go to the next step after that. So this is one another use case perspective which is useful from the design aspect. Then another use case is focusing on the layout, where you simply, similar to the EDA system solution, you use different kind of agents or different kind of models to parse the data, and then make sure that your routing algorithms or the layout is correctly done, and you are verifying your DRS automatically using these systems. So those things can be fairly automated otherwise, instead of manually laying it out, verifying everything, running uh, the verification step of whether the DRM and the DRC checks are being correctly optimized or not. So all those things can now be actually, you can give it to a backend system, and then they will do it. And another aspect could be that if you are laying out your usually you have to wait until you can wait until a point where you can then start your layout phase. So maybe there is a smarter way that as the design is progressing, the layout part can be auto generated to a certain extent, and then the layout engineer can review it and then see if something needs to be changed, and if there is any impact on how the metal or the different layers are interacting, or is there any violation rules which that particular engineer need to look at. And then also running some kind of cross checks, like whether there is any PDK level information which we missed or has not verified. So those can be given back to the system, and then that can be verified while somebody is working on the next step of the design stage. Now, another example, and one thing on which I wrote about a few years ago, is computational lithography. And so, in a very nutshell, what happens is that as you go down the lower end of node, like as you're shrinking your devices, it becomes very difficult to replicate and turn the mask in. So, because the more smallest the node is, the difficult it is to understand what kind of form factor it will have. So what there are few companies which came together and came up with a process of which they call as actually, I would call it as reverse lithography, where they try to predict what will be the shape of the device or shape of the particular uh, particular device character which you are developing, and then reverse engineer it to come up with the mask which you are generating. So this is actually helpful because you really don't know what kind of deformity that can happen when you are working with much smaller nodes. So this is where it the like companies like NVIDIA, ASML, Cadence, and Synopsys came together and said, "Hey, can we use some kind of mathematical models to actually predict the kind of mask which we need to develop for the let's say sub 2 nanometer, 1 nanometer, because everything will become very much complex, and you will have much complex design, and you will have multiple mask sets, let's say 10, 20, 30, 40, depending upon how the complex SoC is. So this was the kind of sort of a prediction based solution which they have developed to understand how exactly we can use AI to understand actually what will be the mask, how we need to generate, and then create that, rather than using a standard GDS process to design your mask set. And another, so The last five aspect which I shown was like design phase, where you are trying to understand your specification and creating a base layer. Then EDA tools, which you everybody uses on the design stage, and how they can be made smarter by using these different models. Then once you're done with the design, you go to the layout phase, and how layout can be speed up and made faster using these tools and solutions. And then on the manufacturing side, one use case is how do you predict the shape of the devices when it becomes very smaller, and your current existing lithography system is not able to predict it. So, but this it doesn't end here. There is a big list of different kind of perspective which will come into picture, and every stage where you will see in the product development, the influence of smart solution will come into picture. For example, during testing phase, we could be so testing is mainly two types of testing. You are either doing it on the bench board, or you're doing it on an automated equipment system. Now, when it comes to bench board, you have to like wire system up and then run scripts if it's a memory based, or you have to run some oscilloscope, some kind of instruments to capture the data. But when it comes to automated tool equipment system, where you are actually probing the wafer or the packaged parts, that requires you to develop test programs. So since there's already a lot of influence on generating the text using AI models for any advanced AI models, pre-trained models available, then the goal would be that you start creating code using these kind of solution, and then you build upon that. So you don't have to write it from scratch. So those kind of techniques have started to come in. The adoption rate is a bit slow because it requires you to initially you cannot trust it, and maybe it's easier to use the templates for that particular product from the previous cycle, but that's where things are heading. In assembly, it's already being used. There are already algorithms deployed to capture whether, as I said, whether the package has any defect, chipping, or if the laser marking is correct or not. And fabrication is already slightly advanced. So in a nutshell, the my goal of this slide is to show that any process step which we have in the silicon development stage is actually going to get influenced by some AI solution, or whatever has already been influenced will get a step up. So it's not like if you are in one domain or the other, you cannot take advantage of the AI solution. It's all about understanding how you are going to integrate this kind of new tools to your process steps, and then take advantage of it. So what I have done is I have created one basic example, and I just want to check so far any questions for me.
No, as far no questions in the chat.
Okay. So what I'm doing is that this is Chat GPT, and I know that many of us have already used it. So what I was doing in okay, so what I have done here is that I have taken a very well-known product type which we used to use a lot, 555 timer, and I'm taking a look at the data sheet here, right? And what happens is that this data sheet is actually any product you see in the market has a data sheet, and that data sheet actually tells us how to use that product. But when you are actually fabricating this, you are testing the chips for these kind of specs, right? And to check these specs, you have to use a system called as automated test equipment, or a system where you can actually put the part and see if it works in the range where it is mentioned. Now, let's say if I am a test engineer and I want to do things smartly using the AI options which I have, and right now I only have access to, let's say, this interface of ChatGPT. So what I would do as a smart guy is that I will take a data sheet, make sure it is secure and everything, and then I will put it in the system. And this data sheet is available in the public domain. And I've already uploaded the data sheet and said, read this and just hold for me for next instruction. So when I'm interacting with this tool, then I can tell it, I can write a prompt here where I can say I'm working with 93K ATE tester and I want to write a spec in Smart Test is a tool which ATE vendor Advantage uses. And so if I give this kind of prompt, then I'm expecting this tool to read that data sheet, look into the critical spec, or if there is an identifier to identify it, and then write some kind of SMT7 code and give me an output, right? So it will try to do that and will write it some functionality for me. So some of the critical spec would be, how do you define the supply current, how do you measure it's correct, and how do you set it up, and then it will tell me how exactly I can check this threshold, and then looking into all these aspects, and then it will generate a snippet of code for me, like this is how you can actually look into the code and test it out on the platform. It's not as simple as this, but at least whosoever is a test engineer help will identify how to take it forward, and then it will create a test flow for me and then make sure that I understand which steps to look at and how to set it up. So imagine a scenario where I am starting as a semiconductor engineer and I do not have everybody access, like everybody is occupied with their work. So I can now go to a tool and actually start fiddling around and learn about another system which I've never used. At least it can give me an idea about how exactly that system works. Another way to look at it is that you are working on some kind of product development and you want to write a test program for it. So initially you can generate some kind of template using these kind of tools, and then that could be a base platform where you can understand how to look into different tests and how to actually measure it, right? And another thing would be, let's say today I'm using SMT7, but right now the industry is slowly moving toward SMT8. Now, how do I tell it that, now I have written the code in SMT7, I want to transition to SMT8. So there are two ways: I will manually do it or I can ask the system. So I can tell it like, instead of using this, I can copy it here and tell, can you write this in SMT8 format? So now it will understand that SMT8 would include sort of a Java methodology. So it will actually translate my code into SMT8. Now, whether this will directly work or not is definitely not given, but you can at least speed up your process of transferring the test code from one version to another without actually focusing more on the manual process. So these are the kind of basic examples that can be used where you're actually using a trained system to enable yourself being much more productive of where you want to test it. And another thing to note here is that right now the system I'm using is actually very generalized. It has a lot of information, not just about the ATE system or kind of uh, code it is able to generate, but if can happen that you can take some kind of reference open models and then start feeding it information using I will show an example at the end of this talk, and then make it much more case specific. So maybe a model that is only going to focus on generating test code, nothing else. If you ask it about design, it will say, I don't know, because it has been specifically trained to do data code generation for your ATE test platform. Now, let's say if I'm a intern and I don't know what ATE system means. So I can also query the system and tell it, can you show me examples of how. So if it goes through this, then it can give me some example, how it looks physically, how what a handler is. So basically, handler is where you put the device and it will start automatic testing of thousands of parts. You need to have a load board. You will have a tester and you have different systems. So these kind of things you will not learn until you have a system which can give you some kind of knowledge. And nowadays it's just difficult to read through thousands of pages of book. So you can also create what all type of hardware I need to develop in order to test. So basically you cannot just go and test the 555 IC without any setup, right? So you need to have, it will tell you that you need to have load board, which is basically where you will have PCBs. On top of it, there would be location for socket and you will put the part in. So this is what you would need. You will need some kind of external networks. You will need sockets where you can put it, some kind of components, some kind of devices, instruments for tester, handler, and then some anything which is needed in order to make sure it can bias this particular device. So this is a very basic example of how one will be able to use it and then take a step forward of how to develop the test program for your platform. And another example which I have is from mostly on the process step, and it's more about information gathering and looking at the different data points. So we all know about open source PDK from Skywater Fab, and they have collaborated with Google and few others fab. They have open sourced this PDK revision information for 130 nanometer. So imagine that you want to learn this tool and understand what are the features, characteristics, devices. So you can just take the link of this open source and then you can tell it like read about So you want to actually understand what type of characteristic different kind of devices which are supported by this particular process steps offers. So it will go through it and look at it, what kind of transistor it has, what is the voltage references, NMOS, PMOS, and different kind of devices, what level of voltage, whether you have low level devices, high level devices, so that you can understand what specs you can have in your data sheets. And then different kind of memory solutions which it can provide, and it will give you the table. So this is another way to learn and gain the knowledge about a specific tool or specific PDK, so that you can actually look at different characteristics. Because otherwise, what second best option is that you go through a PDF document that will describe each of this, and then you will have to read all the information apart from what you don't want to read, right? So basically, the goal here is that you can use AI solution not just for your own product development phase, whether you are writing code or whether you're looking into trying to understand how to write this RTL or the SDL code for this particular block, but you can also use it to understand and learn about a particular solution. So this was a brief example about how one can do it, and so there could be several use cases based on how you want to use it and then take it forward. Now, one last aspect which I wanted to focus on was the skills for semiconductor professionals in terms of AI. If you want to be ready for what is coming, and if you want to understand whether you are doing a research in this domain or whether you're developing products, so what kind of skills you would be needing. So there are some basic things which you will have to understand, like which domain, first of all, you will be part of, whether you are part of finance, business, research, chip design, manufacturing, and then start exploring solution, like at least have a basic knowledge about, how to use the tools. What I showed was a very basic example. So how to use the tools. And then if you already have access to some advanced tool within your company or your lab, then fiddling around and looking at how AI features are integrated in and how actually they can help you. So this would be more about, asking the right question and looking at the right features. So because if you don't know what to ask for, then you will never get what you need, you're looking for. So that is where exactly your that skill set will come. It will more about, learning those extra features, like understanding how to write prompts, how to which models to use, actually we won't, as a user we will never have a say on the models, but at least the how to use that feature, not by click but by using more queries, by whether it is voice enabled or whether it is keystrokes. Then not trusting that, like, data analysis skill would be always be useful when you're dealing with AI, because you cannot just trust the data which is presented to you. So you have to look and understand whether, is the outcome making sense, is this really what is the right process step is. So this will be a mix of what already possessed technical skill one engineer has, and then making sure not to blindly trust any data or any kind of outcome is there. And then it's more about generalized skills, how to uh, uh, integrate this AI in the system so that everybody is on the same page. And then not just that you are running away with the AI tool and you're saying, okay, we will do it, but you have to bring the product into that level that where everybody who is on in your team is able to use the solution, so that you can make it more the system can be much more better. And one last slide which I want to show is that, so this is the actually I forgot to add a caption here. So this is from SR's Semiconductor Research Corporation's study for uh, package level different domains, and then they came up with this function versus skills correlation. What is going to happen is that we will have these basic functions where we have layout designer, analog designer, quality reliability, product engineer, process engineer, industrial engineer. But apart from these critical skills which are listed on top, which are just the basic known solution, you also will need to understand that how the smart AI skills or tools will impact this, whether they are going to make some of these redundant, then how do you replace this with some kind of understanding about the tools, or maybe developing the tools on your own. It could also happen that you might want to slowly get access to some kind of solution where you can actually subset it and use it for your own use cases, so that you understand that your knowledge base is driven by the solution you have developed based on the larger system. And that can happen because even today, if you go to any kind of whether it is Anthropic or whether it is ChatGPT, OpenAI, wherever you go, you can actually train that model to only do specific tasks. So those kind of things can be done using the skills. So the goal here is to show that, right now we are saying that these are the critical skills, these are the functions, but each of this function needs to be understood how it will be getting impacted by AI, and then how to make sure that you integrate yourself in these domains and then drive it towards what you really want to work towards. And one thing which I could not set it up on my system, but what one can do is that there have been some research work around, making sure that the semiconductor industry is not just relying on generalized models. So there are collaboration being done, and there is some models out there which are actually focused on semiconductor knowledge. And this is one of the tools which is called a semicon. And what they have done is that they have taken the data set details from different sources like books, papers, research, and some kind of manual data feeding, and they have trained it to only make it much more smarter toward the semiconductor product knowledge phase, so that anybody can go and query some kind of solution, and then that will give you a very structured response. So this could be a very good starting point where you are actually starting to set up your system and looking at a specific domain, and then building on top of it and then seeing how it's done. And one thing which actually I forgot to show you is that, for example, this was something I wanted to show earlier. So there is a system called as Olama. Olama is actually a sort of a software tool where you can gather majority of models available in the domain. Now, if you want to learn about AI on your own, then the best way is to use some kind of tools like this where you set it up on your system and you act. So I have already done this on my system for one of the models. So for example, I have done it for Gamma 3, and if I ask it to run it, so that will actually run this model which is already pre-trained on my system, and then I can query it to give me some kind of structured output. And there are ways to also train this model with your own data set if you have it, and then you can make it much more personalized and focused on that. So for example, so this interface is command line, but it is similar to what I was showing in the chat GPT as a use case for AT test code. So you can also write it. Give me an example of. So it understand, even though it's running locally on my system, it can give you a view of how it is able to explain what the AD system is, how it is written, what kind of code it is. And this is just a basic example of how you can generate test patterns for a specific, very random example as a pseudo or dummy code, and then go deep into it and ask much more specific query. How do I measure this particular spec? How do I look into this parameter and all those kind of things? And then just replace those with some design questions and then run it. So right now, this Semicon is not on Olama, but it's already available to download, which can be a good starting point if you are trying to get started. How do I learn this AI? Because to be very frank, as a semiconductor engineer, we won't be developing models. Like, we just want to understand how we can use it so that we can better our skills in terms of our technical skills. So this is where I will end. And if there are any questions, then I would be happy to answer.
Yeah, thank you very much, sir. It is a really insightful session. Yeah, participants, is there any query? You can post in the chat.
Sir, it was, hello.
Yes.
Yes, sir.
Speaker has nicely covered the various AIML possibilities in VLSI. So here is Dr. Manish Patil from Nirma University. One of the question is there any ecosystem developed for some sort of generic data set that can be used for this purpose? This is valid for other domains like image processing or natural language processing, but similar to what you have saw on two platforms. So
yeah,
if you have came so apart from this, so that is good one. I will look at it. Semicon.
Yeah.
And is there any other way, if you are aware of, where the data sets can be considered for using and later on it for comparison with other sources? So these are the two challenges I am facing right now: data set, and later on for comparison, whatever the task, whatever the work we did, that cannot be easily plug in with the commercial idiot tools to know the improvement in our approach. So data set and how to compare our work with the existing tools.
So let me think if this is the. So there's this repository on GitHub, and
Okay.
Sorry, I'm looking at the right. So right now the closest I know about is this data set, because there was literally no trained data set for semiconductor reference only, and there are list of there's one lab which has actually. Let me see if I can quickly find it. Yeah, so there is one, this repository on GitHub. What they have done is they have collected a set of different research papers where they are only focusing on how advanced algorithms are being deployed, mainly from the AI, pre-trained transformers, and etc. So possibility is that one of these paper might have open source some of the trading data set, and that could be one another source to look at. If because this specifically is mainly on anything related to using advanced tools and focusing on verification, EDA, code analysis, mainly using large language models.
Okay, thank you. So I will look at it. And the other thing, just if I wanted to know, recently in our small group of students, and I have started working in this domain. So is there any possible collaboration with you in any of the project or any of the thing that we can work jointly, Mr. Chetan?
Yeah, I'm always open to discuss. As long as I'm able to help, I'm more than happy.
So sure, I will communicate later on. Thank you.
Thanks.
Thank you very much.
Any other query from other participants? Yeah, student participants.
For students is going to be very important. So I hope I'm pretty confident all the students are already using smart tools, but yeah.
Some of the things are new for them, so maybe they'll take some time.
Yeah. But this is coming. So industry is heading towards this solution, and it's not like something to worry about. It's more about making sure that your VLSI knowledge and skill set are getting translated using these better tools. Because if I'm a student today, I would like to stay ahead using these solutions. Otherwise, you don't want to be left behind.
Yes. So participants, any query? Otherwise, we'll wind up the session. Thank you so much, Chetan, for giving us your valuable time at odd time.
Yeah, no problem at all. Thanks, everyone.
Thank you.
Thanks. Have a good day. Bye.
Thanks, everyone.
Yeah. Thank you, sir.